I'm Shitong from UC Riverside, and this is a collaboration with Xunchao from Syracuse University, and of course my own advisor, Professor Zhiyun and Professor Zubair Shafiq from the University of Iowa, and Professor Heng, also from UCI. So basically, I'll be talking about this, our work on measuring and disrupting anti-adblocking using some differential execution analysis techniques. So here is what's happening, right? We're running into all kinds of flashy, intrusive, and annoying ads every single day. And sometimes even worse, we have been tracked. So basically, this is so-called targeted ads, right? So sometimes this insane conciseness and the creepiness kind of freaks me out. And for a lot of people, being tracked is not like we do have some options. It's basically a mandatory part of the targeting advertisement. So this is pretty bad. And sometimes even beyond that, we have malvertising. Basically, malvertising is some malware propagated through the internet by the online ads. Then, so ads industry has made their move. What is ours? So basically, here's our weapon, the ad blocker. According to this report from PageFair, 11% of the global internet population is now blocking ads. So it's a huge deal. So how does an ad blocker normally work? Basically, ad blocker is a piece of software installed in our browser as an extension, and it has a very long filter list. So whenever you put a request to ask for some resource, it will check against this long filter list. And if anything you are requesting is on the filter list, it will be blocked. This is the basic mechanism. So OK, we've made our move. What does ads industry think further? So as a response, they are basically not very happy about ad blocker. They consider ad blockers a serious threat to their business model, which is true. So here's their move. They try deploying this thing called Anti-Adblocker. So Anti-Adblocker is some JavaScript code employed at their client-side script. So a normal Anti-Adblocker has two parts. The first one is to detect the presence of ad blocker by either checking the deployed ads element in the web pages or some extra JavaScript file if they are loaded correctly. And then it has its reaction part, right? So for reaction, it can choose from a list of options. It can either completely or partly block the real content, or it can issue some warning messages basically saying that, OK, we've detected you are using ad blocking. Please disable your ad blocker to support us. I believe some of you are running into this kind of messages from time to time. And also, they can silently report this ad blocking status to their backend server. So this is some phenomenon we discover that are way more pervasive than we thought before. So this is kind of a new point. This is a typical warning message issued by Forbes.com. You can see you can either whitelist their website or you can just subscribe. You can just pay. So we see this. So this here, once again, it's coming to our move. So we see this already an escalating arms race with no winner yet. And our goal is quite straightforward. We want to investigate this ongoing arms race. And with this valuable knowledge, we want to escalate this arms race further. And also, before this one, we had some prior works. Basically, our IMC paper shows that the coverage of the current anti-ad-blocking filter list is not very good, which is, by the way, the state of the art officially adapted by the ad blocker to counter anti-ad-blocker. But it's not very good. And also, we have this pet paper making use of the A/B testing, trying to automatically find out if a certain website is doing anti-blocking. And it's based on the static analysis, basically working on the HTML DOM elements. And it only works for visible anti-blocking. So basically of those who do issue the warning message, not about the silent detection. And also, it cannot pin down the relevant code in the JavaScript file. So basically, now we want to overcome these difficulties we encountered before. Now I'm going to present our latest move, which is the differential execution analysis. So here is our key observation. It's quite straightforward, actually. So if a website employing anti-adblocking, then we assume that it should have a different JavaScript execution trace if it is loaded with the ad blocker, which in this case we call it the positive trace, as compared to the situation without ad blocker, which in this case we call it negative trace. So this is still a form of A/B testing, but this is now done dynamically. So how do we actually do this? This is our system overview. We instrument our browser, the Chromium, and load the same page with two settings, one with ad blocker and one without ad blocker. And then we feed the positive traces and negative traces to our differential trace analysis engine. And then if we find any branch divergence or conditions, we basically say, OK, got you. We have detected this anti-adblocker, and vice versa. That's the basic idea. So let's take a look on a typical code snippet of anti-adblocker. Here is a very representative example. So you can see here this if statement tries to detect if a certain ads element in the web pages are still there. Are they still present? If so, it will alert, issue some warning messages to the user. And if no, the else part, the then part basically doesn't get executed. So imagine what will appear in our execution trace when we enable AdBlocker. Basically, the then part will be triggered, and it gets executed. And vice versa, if we disable our AdBlocker, only the if check will be executed, but the then part will not be touched ever. So by this way, we can already find the divergence. We can call this anti-adblocker already. So on our ground truth data set, actually our system achieves a very good number. For the true positive, it's almost 87%, and for false positive rate, it's just 0. So we didn't find any false positive cases in our experiment. And also beyond, as I said, beyond the binary results telling you that if a certain web page is doing anti-blocking, now we can do more because we have more information. Here we have the position corresponding to the exact part of the code doing anti-blocking. This is some information we didn't have before among other works. So here's our key finding. We found that anti-adblocking behavior is more pervasive than we thought before. Now the number is 30.5% among all the Alexa top 10K websites, which is basically roughly 5 to 52 times more than reported in prior literature. So this is a huge, huge gap. So why do we have a huge gap? Basically, you can take a look on this pie chart. Remember, we have our definition of anti-blocker with two components. The first one is detection, and the second one is subsequent reaction. And this part could be possibly silent. And according to our finding, 93% of all the positives are actually silently detecting the ad blocker instead of issuing you any warning message. So that's the reason why we have a big gap compared to prior work. So here's a typical example of silent detection. This one makes use of Google Analytics. Basically, whenever it finds you are using ad blocking, some ads element disappeared from their web pages, it reports the situation to the backend server of Google Analytics. So you can check later to decide what you will do in the future. So here are some other findings. We found the regions of top scripts containing anti-adblocking logic, including most of the major players in the ads industry. DoubleClick, Taboola, PageFair, of course, because it's a dedicated third-party anti-adblocking solution provider, and Yandex and some other companies. So this is, we would call it a huge deal. Also, the popularity, so the higher a website is ranked, the more possible a website is equipped with anti-adblocking piece of code. This is understandable because the more audience you have, the more revenue you are losing to the ad blocker users, right? And also, after our detection, what can we do towards those anti-blockers? So here we propose 2 ways. The first one is we can rewrite JavaScript conditions. Because remember, we checked out where does those anti-blocking code really reside. Now, we can simply append a false by the end of the if condition. It will force this branch to go to take the falsy branch instead of the positive one. Then basically the notification part will never be executed. But this way is pretty intrusive, right? We still have to ask our users to install some network proxy, which is quite heavy. So the second way is lighter. We can basically hook the APIs inside the JavaScript. So basically, there are a whole bunch of APIs commonly used by anti-adblockers trying to check the presence of their ads element. We can try to force them to return a fake value. So basically, when they try to find out if there's any ads in a page, we always tell them that there is. So they get tricked, basically. So coming to the future projection, our ultimate belief is that users should have the right to make a choice here. And we are now not being offered with many options. We want to change this rule. And also, there are already some innovations in the industry. There are acceptable ads program. There are better ad standards, basically trying to reformatting the ads to make them less intrusive and less annoying. This is a very good attempt. And also, there are some projects trying to do this ad profit redistribution. Brave browser is one great example. It tries to fundamentally change the game, try to offer the users with more options to only pay for your interested ads instead of having to see all of them. So yeah, I guess this is pretty much my presentation. If you're interested, please visit our complimentary material site to check more code snippets of the real-world anti-adblocker examples. So thank you.
Hi, Ben Schock from CISPA. Thanks for the interesting talk. One thing I was wondering about, can you give me an intuition? You had like 13% false negative, right? So you had 87% true positive, so that means 13% false negative. Can you give me an intuition of what types of anti-ad blocking you did not detect, these 13%?
So basically, remember, we instrumented the browser. And this instrumentation has some completeness issue. So there are some special construct besides let's say, the simple if-else conditions that anti-blocker could be using to detect the presence of ads element. So some of them might be, let's say, the callback function. So whenever we have this, whenever a certain resource doesn't get loaded, it will invoke this callback function saying that you are using AdBlocker, and we have detected that. So this situation basically requires us to have a more complete instrumentation inside the Chromium browser.
Okay.
That's also part of our future work. Yeah.
Mm-hmm. And the second question that I have is related to how you did this comparison between with an ad blocker and without. Did you really load the site completely twice from the remote server? Because we heard in the previous talk that like pages change all the time, and the JavaScript that is executed also is like especially if you have advertisement that includes something else every time, so you have different JavaScript code. Maybe you can comment on that, how you did this evaluation.
This is a very good question. I'm happy you brought this up. So the thing is, we have this basic assumption. So any divergence we found should be directly relevant to anti-ad blocking, right? So we have to, as you said, we have to handle a lot of JavaScript dynamics. But the solution we came up with is we try loading this very web page with the ad blocker disabled, let's say disabled, for multiple times. So we keep the ad blocker closed, but we still load it with multiple times. Then we filter out those positions that already have some sort of divergence because they are guaranteed to be irrelevant to the anti-blocking. That's how we handle this issue.
Okay, thank you.
Thank you.